15. We have, what is the Lewis structure of NaOH? We want to fill the octets with lone pair electrons and assign a formal charge if available. Well, as you can see, the Lewis structure is right in our faces. It says it's Na single bond with O, single bond with H. But now let's see, how did they get that? So Lewis for NaOH. Okay? So, with this being said, we can actually approach this two ways, but what I'm going to do is approach it the way of the hydroxide starting there. So funny enough, hydroxides, okay, this is something you have to memorize because it occurs very frequently, is known as the OH minus. How do you draw the Lewis structure for this? So oxygen has 6 valence electrons, hydrogen has 1 valence electron, and the minus indicates we add 1 more electron. So in reality we have OH, like that, bonded, and then we have like that. This right here will be the Lewis structure for OH minus, okay? Now, what happens here is that sodium, okay, because it always, like as an ion, it got rid of 1 electron, it would just be Na plus. This Na plus can actually just go right here and just attach itself, because Na plus has no, what's it called? Na plus has no valence electrons because they got rid of it. So that's how we can just kind of slide it right there. And this actually would be the Lewis structure for NaOH. Obviously, you convert that electron to a bond, but even then, I actually leave it like this only because NaOH, that's when we are working with ionic, a metal and a non-metal. So in this case, this is actually what we would get, NaOH. So now in regards to this, it asks us to fill the octets with lone pair electrons, which is what we've done. And it's also asking us to assign a formal charge if available. Okay, so let's see what formal charges we can do. So if we redrew this to where it just has NaOH, okay, we can actually now say that, alright, so what is the formal charge for each one? Sodium by itself, theoretically, just have 1 bond, which is what it's doing there. So its formal charge is 0. That one's good. Oxygen, on the other hand, would like to have 2 bonds and 2 lone pairs, which is also what it's doing, so it is satisfied. And hydrogen, the last one, just likes to have just 1 bond, and that's also what it's doing. So this, all the formal charges would be 0. Okay? Now, for the last part, let's make sure we have the correct amount of electrons. So hydroxide, as I said, we're working with 8 electrons. Now, funny enough, when you actually look at NaOH, it'd be the same thing. Sorry about that. Just trying to close this, but this won't close. There we go. So with that being said, NaOH, if we actually went through that as well, we have Na contributing 1 electron, oxygen is 6, hydrogen is 1. It actually is also working with 8 electrons. As you can see here, we have 2 bonds, which is 4 electrons, and 2 lone pairs, which is another 4. So the Lewis structure for this would indeed be that. Okay? And that is what we have. Formal charges are all 0, and it is indeed NaOH. But funny enough, I still like this picture better, because when you do put this in a solution like water, we have the Na plus by itself and the OH minus. And the reason why it's like that, because the oxygen, this is what you call Ionic Shift, where the sodium actually did just pretty much give its electron to that oxygen, which is why we have the OH minus. And funny enough, this would actually be a formal charge because it got rid of the bond, right? It should be a formal charge of +1, and the oxygen here would have a formal charge of -1. And you can see how in total they end up with a net of 0, but when you put it in water and dissolves, you can now see the formal charges come out of it. So, with that being said, let's move on to question number 16.